So now let's understand a few properties associated with union of sets. Let me take a proper color, a different color, so that I could, yeah. Okay, so the properties of unions of sets. First is the commutative property. So commutative property, it basically means to commute, to move a variable, to move a set from here to there, so that you can build up a association or a relationship. Okay, so in commutative property, like we discussed in our intersection of sets, commutative property also holds true for union of sets also. So A union B is equal to A union B union A. So let us again take an example. So you have A, so I will take, say, 0, 1, 2, 3, 4. Okay, and now let's consider another set which is having 5, 6 and 2. So here the commutative property says that if A union B, we can check whether A union B is equal to B union A. Okay, so let us check. So let's do A union B. A union B gives us a set 0, 1, 2, 3, 4, 5 and 6. So why did we write 2 only once? Because that is the difference. You only have to write the common elements of the two sets only once in a union. Okay, so a set will always have a single element or common type of single element. So just remember, and now let's do the union of B union A. It will come to the same. So the commutative property holds true. What I suggest is you also come up with your own examples and sets to define how commutative property could be defined, and so that you could have an example which you yourself have done it, and there is an understanding and that front. So, and at the same time, if there is any set which you are not able to form in a commutative way, let us discuss it over here. Put it in the comment section so that we could discuss it. Next, the associative property. Associative property, as you remember, it is when you associate, when you group. So associate, when you group the sets. So grouping of the sets happen this way: A union B, A union of B union C is equal to A union B union C. So if this is also true, you could find this also. So let's take another set C. I'll just rub this off. Let's take another set. We'll take 1, 5 and 7. Okay, so let's find out A union. So first, according to DMAS, we need to first do the B union C. Let's see what B union C does. Let us do it here so that we have some space now. We have only this much amount of space left. So what is B union C? B union C will give us, so union is basically combining the elements of both the sets B and C and repeating on the common elements only once. So 5 is a common element. So 6, you have 2, you have 1, and you have 7, right? And now this we have to have another union of this set with A. So we will form A union B union C. Now let's find out what A union of this set gives us. So curly brackets open. So we have 0. 1 is a common element, so we'll write 1 only once, and we have 2, we have 3, we have 4, we have 5, we have 6, and we have 7. Okay, so we have combined A union B union C, A union of B union C, so which gives us 0, 1 being a common element, it is repeated only once, it's put only once. 2 is also a repeated element, so we put it only once. 3 is also, no, 3 is not there, so 2 is a repeated element. Then we have 3, 4, and we have 5, 6, and 7. So now we have the LHS part, which is of the associative property which we are looking at. Now look at the RHS part of that, and let's find out if LHS is equal to RHS. Okay, so in LHS we have got A union B of union C. So let's look at A union B first. So I will directly write the elements of the set. Okay, so just carefully look at both the sets and see for yourself which is here at the top. So A and B. Okay, so we have, so union is basically combining all the elements in a particular set and keeping the common elements single. Okay, so 0, 1, 2, 3, 4, 5, and 6. So that forms our A union B, and after getting this set, let's find out union with C. This particular set's union with C. So we have just one element which is extra, which is all the elements 1, 2, 3, 4, 5, 6, and finally we have a new element from C which is 7. And you can see both the RHS value and the LHS value are same. So here we have even found out if the associative property holds true or not, which also holds true. So now let's do the distributive property. So as usual, I have less amount of space here. So let me draw a separator over here. So we are looking at the distributive property, which states that A intersection B intersection C. So let's look at the first one, and I'll take a different color so that we know which one we are heading for. Okay, so I am looking at this one first. So let's solve the LHS part and then the RHS part. Okay, so in the LHS part, let me first decipher B intersection C. So B intersection C. So intersection is basically forming a set of the common elements which are there in both the sets. Right. So refer to B and C, and let's see what are the common elements. So 5 is a common element, that is all. So it's a singleton element which is 5. So it is a singleton element which is 5. And now let's see what A intersection of singleton element shows. Okay, so it will show basically. So if A has 5, no, A does not have 5. So you don't have anything in common. So what will it return? It will return a null set. So that is 5. So now let's see the RHS. So LHS we have got it as 5. PHY. Okay. PHI rather. Okay. Now look at RHS. So first we will look at A intersection B union A intersection. So let's do this part first. A intersection B. What does it show us? A intersection B. A intersection B. So intersection is grouping of common elements in a particular set. So let's see what are the common elements in A and B. Again, common elements are only one, which is singleton element 2. Okay. So now we have another element, another A intersection C. What is the common element on A intersection C? So A intersection C has 1 as the common. Okay, 1 is here, which is the common element, which is the point of intersection for both these. So you got singleton elements in both, and union of those two. So union of those two is basically 1 and 2. So which is, in this case, the LHS is not equal to RHS. So the distributive property is not holding true. The first one is not holding true. So let's look at the second one. So I should rather write this as not as 1 comma 2. Should rather write it as because since it is A union B in A intersection B union in A intersection C, which is actually 2 comma 1. So in this case the LHS is not equal to the RHS. Okay. So now let's look at the second one. Okay. So first we will do B intersection C. B intersection C we have done it here. So let's take a singleton set 5. Again it is A union of this. So you have A. What is A? A is 0, 1, 2 and okay. So you have A union 5. This basically you have all the elements of A and the 5. So it is 0, 1, 2, 3, 4 and sorry, I missed out 3. So let me rub this off and yeah, so I have 3 and I have 4 and I have 5. Okay, so now this is our LHS. So LHS, I'll just write it down here. LHS. Now look at RHS. RHS is the right hand side. So now we have in RHS we have got A union B and A union C. Okay, A union B is, so you got we have 0, so we have A union B, which is 0, 1, 2, 3, 4, 5 and 6, right? And now you need to find out what is A union C. A union C is 0, 1, 2, 3, 4, and then you have 5, and you don't have 6, you have 7. So now let's find out what is intersection of both these two sets. Let's write it over here. So intersection of both these sets are basically you've got 0, you got 1, you got 2, you got 3, you got 4 or 5, and you got, that's all. So you have right from 0. So I will erase these two. So you have a set which is same as the above. So the set goes 0, 1, 2, 3, 4 and 5. So this, in this case, our LHS and RHS hold true. So they are equal. So the second, this particular distributive property where A union of B intersection C and is equal to A union B intersection A union C, right? So in this case it holds true. So the distributive property, the second property holds true. So now look at, I have done till here, and I want you to do the fourth one, the fifth one, and the sixth one, and the seventh one. Put it down in the comments section. See if you can understand and do these on your own. And now once you have any difficulty, you can subscribe, you can like put it in the comment. I will make a separate video for these 4 if you want. And these are pretty easy. Once you've got the fundamentals right, you can easily do these 4, 5, 6 and 7 on your own and find out. But just remember, these are the basics and the foundations for operations on sets, and these are part of the union of sets which we are discussing right now. So keep these fundamentals in your mind. Take a sheet of paper, separate them out, keep reading them on and off whenever you are free, so that all these fundamentals are right into your core of your mind, so that any time you see such a commutative or associative property sets or distributive property sets, you could easily identify them. So that is the fundamental thing which you need to do. So that will form your basics, and with this we complete our union of sets. And now we will continue with difference of two sets in our next video. In the continued video, actually it will be part of the part of this video only. So just take care, if you take care and look at all these properties, keep them in mind, keep a separate note of them, even though I have scribbled a lot. So you could always go back and pause the video and see where everything is clear. So write them in a piece of paper, or you must be having the same thing in your textbook. I have taken a different set of examples, so you could take your own examples of all these sets and do them yourself, experiment with them with different sets. Okay, so if you like this video, click on subscribe, ring the bell if you want more notifications to be made, notifications, and give me a thumbs up if you really like this and you want to go ahead with this video. Okay, take care, bye.